Hello my dear champions, welcome back to our channel Deeksha Karnataka. Today I'm here to discuss the theory part of the chapters Trigonometry and complex numbers from your PU1 syllabus. Okay, so we got to be very much careful over here. The chapters sometimes seems like tricky, but they are very simple if you know the concepts well in complex number and if you know the formulas well in trigonometry. Alright, so let me start the session right away because I know your time is very important, and let's learn the theory. Again, as I'm reminding, this is just the theory class. For practice of PYQs, we're already doing that in 15-day challenge. Okay, so let's focus on the theory part right now, so that if we have any gaps in our preparation, we can fill it with our this session of preparation of theory classes, okay, or the concept part. All right, now before I proceed, I have something to show all of you regarding about our ABHYAS test series as well as KCET 30-day crash course. So if you are still figuring out which one to take, I've taken the entire comparison over here. So basically bacha, if you are serious and you have time right now, you can prepare for your test series right away as well, from the test series right away as well. So you can take in the ABHYAS KCET test series, which is priced at 999, you can take 30 plus mock test which is there, which has both type of mock test, full syllabus as well as part syllabus mock test. In the previous year, your seniors told us that they actually found the part test very efficient because it was given for part syllabus and they were able to complete a chapter and complete few chapters and write test on it. So part test also available as well as full length test, comprises of PC, MB, means physics, chemistry, maths, biology, all is covered over here with 30 plus mock tests. So please go ahead and take it up. If you have a good clarity in concepts, you want to just practice off questions and different type of questions just for CET, a very experienced team at Deeksha has made this. So trust me when I say one of the best in Karnataka, it is one of the best in Karnataka. Okay, so this is your ABHYAS KCET test series at 999, and for the crash course, for somebody who wants to have personal attention, individual guidance as well as complete packaged altogether, even though the series already started on 21st of March, this test series, this crash course was live from 21st of March. But if you want, if you can study still right now from today itself also, you can cover most of the things over here as well. And what is the offerings of the crash course? You are getting this at 2499. You're getting 10 mock tests. These are the mock tests which is separate from the ABHYAS. If you have taken both, you'll get 10 different mock tests over here. Okay, it's not the same thing. 10 mock tests over here. Full syllabus coverage is going to be given, means you're gonna find. And good thing is that lectures over here of syllabus coverage and PYQs are recorded in nature, means you can watch at your own pace. If you have a good grasp in a chapter, you can just revise it at a faster speed. Okay, so full syllabus coverage of, and there you also have the PYQ also covered for the syllabus of PU1 and PU2 both. We have not skipped anything. Okay, and you also have live doubt classes every day, subject wise. You can again once you join, you'll get to know the schedule. So join right now, whichever is your preference. If you cannot take crash course, at least try to take your ABHYAS KCET test series. Very important and very relevant for all of you. Okay, so this was the clarity I wanted to give. Now let's start the session itself. Let's start the class. Trigonometric function, let's look at this also. So over here, what's important and what we're going to learn and recall is our quadrant rules, our basic trigonometric ratios, and we'll have to learn some identities. Okay, so we have learned the basic ones in our grade 10, but over here we have to learn more and more identities. There are many actually, double angle formula, half angle formula, sum of angles, difference of angles, product of ratios. All these formulas are incorporated and very useful. Conversion of sine to cos, sine to tan, all these results are important to solve questions in trigonometric functions, trigonometric equations, and also as a base for ITF and calculus. Okay, so you got to know all the formulas. Don't worry, I'm going to give you all of them in the session itself. Okay, let us begin. Okay, so before we proceed to the ratios, let's learn some basics. And when I say basics, I mean even the questions can be coming from here as well. Okay, the conversions of the angles, okay, the degree measure to radian measures, angles are very important. What are the angle? Let's just look at that right now. What is the angle? The measures were between two rays like this. If I take this as A B and the point as O, then the movement of this, let's say I take two lines overlapping O and OB, then how much OB has moved from the A in this direction of anti-clockwise is called as the angle theta. I can write this angle theta in two ways. The angle can be written in the terms of degree and radians. Okay, we have two measures to measure an angle. Basically, the amount of rotation. As I mentioned, if OB was lying on OA and it is moved like this or rotated like that, then how we measure this rotation using these two measures. So clockwise, anti-clockwise, I can move ahead and do the same thing over here as well, right? Let's say I had OA over here. I went with OB dash like this, let's say. Then the angle, if I go like this, the actual way to represent the angle is this only theta, but sometime we can go and measure from this way as well. That's called as clockwise rotation or clockwise angles, and this is anti-clockwise angle. Standard, we use always anti-clockwise angles only in all our results, in all our formulas. Okay, great, sir. So you basically how to find that? Using your complete angles difference. 2 pi minus theta will be your theta dash. What is theta dash? 2 pi minus theta is the theta dash value. Okay, sir. Notational convention. We know that pi is 180 degrees. Pi is 180 degrees. That's the standard relation. We know that very well. How to convert radian measure to degree measure? Pi by 180 means if you have any degree value, let's say I have 180 degrees. Put here this as 180 degrees. What happens? This and this will cancel. Answer will become pi radians. So 180 degrees is what? Pi radians. That's a relation you want to know. And degree measure, if you want to achieve from radian measure, simply put over here. Let's say I want to find the degree measure of an angle pi by 3. Then multiply here 180 by pi cancels. 3 times 60, answer becomes 60 degree. So the corresponding degree measure for the pi by 3 value is 60 degree, of course. Next is standard angles and their ratio, sine, cos, tan. So of course, I know all of you know this value very well, but I will give you a hint to learn and remember these values quickly. Okay, so sine 30 is what, sine 0 is what, you all know that. But there is a trick to know this. Simply write in sine, 0. 1 second, guys. Right here 0, 1, 2, 3 and 4. Divide each of these by 4. Divide each of the result by 4. Take root. Excuse me. And get the result. 0 by 4 is what? This value is how much? Check here carefully. You'll see. This value is, sir, 0. What is this value, sir? 1 by 2. What is this value, sir? 1 by root 2. What is this value, sir? Root 3 by 2. And what is this value, sir? 1. Okay. This is how we get the results of sine 0, 30, 45, 60 and 90. This is how we can remember it quickly. Okay. For cos, simply take the, because they are complementary to each other. So simply take the reversal. From 90 you take in 0. So this will be what, sir? 1, 60 to 30. So root 3 by 2. Because they are complementary in nature. This is the same as 1 by root 2. Because 45 and 45. 30 will come here in 60. So 1 by 2. This will be 0. Sine and cos are complementary to each other, right? That's fine. What about tan, sir? Again, tan will be ratio of sine and cos. 0 by 1 is 0. 1 by 2, root 3 by 2 is 1 by root 3. This will be, sir, same thing. So 1. This will be, sir, root 3. This will be 1 by 0 means undefined, sir. What about sec, cosec and cot? That is same, sir, because sine, cos and tan we have, and the other 3 are reciprocal of the first 3. So simply take the reciprocal of sine to get cosec values, sec the reciprocal of cos, and for cot reciprocal of tan. Okay, this is clear how to get the result and remember these values. Moving on. Sign of trigonometric functions in different quadrants. So in first quadrant, the first quadrant measure is what? 0 to pi by 2. Second quadrant is pi by 2 to pi. Third quadrant is pi to 3 pi by 2, and fourth quadrant is 3 pi by 2 2 pi. This is what we have for the quadrants. And in first quadrant, all the 6 ratios are positive. Check here, all 6 are positive. In second quadrant, only sine and the cosec, the reciprocal of sine is positive. So only sine and the cosec in the positive in the second quadrant, means pi by 2 to pi. Third quadrant, tan and cot. Third quadrant, tan and cot. And fourth quadrant, cos and sec. I know you all must know these values, but it's important to recall. I cannot skip this because some of you might have the doubt. That's why it's been discussed over here as well. Domain and range of trigonometric functions. I'm going to draw some graphs and then, of course, explain you the graphs, the domain and range, everything. So first important function is y equal to sine x. How do you draw the graph, sir? Very simple. Again, this will be your x-axis. Okay, positive x-axis, y, negative y, and this represents your angles. You'll have angles over here, and the graph looks like this. Please check. This is your graph, and so on. Of course, it continues on both sides. So this, the maximum value in this graph is 1, and the minimum value in this graph is always minus 1. These values are 0, pi by 2, pi, 3 pi by 2, 2 pi, sorry, that's 5 pi by 2 actually. 2 pi is over here. This is 2 pi, and so on. This value is 5 pi by 2, sir. Okay, this is the graph. So if you see, they are all periodic function, means it repeats after a certain interval, and that interval, that period is 2 pi in this case. Okay, so from the graph, the value of sin x repeats after an interval of 2 pi. So periodic on the interval 2 pi. Okay, what is the domain, sir? X belongs to all real numbers. X will going from all real numbers. Entire x-axis is part of the domain. What about range? Only between minus 1 and 1. It does not exceeds the value of 1, and it does not crosses the value of minus 1 on the negative side also. So the values is what? Between minus 1 and 1 for range and domain. Okay, periodic across 2 pi. Sin x is clear. Cos x. Let's draw this curve as well for cos x also. Again, this is x, negative x-axis, y and negative y-axis. Let's draw the curve. Starts from here. Okay. Again, this continues all the way. This maximum value is always 1, and the minimum value is also, sir, always minus 1. It does not crosses that barrier of minus 1. Okay. This value is 0. This value is, sir, pi by 2. This is pi. This is 3 pi by 2, and this is 2 pi. Again, check here. This 1 repeats after 2 pi. Over here it was 1. Next it is 1 after 2 pi interval. So this is also periodic at the interval of 2 pi. Domain is all real numbers, and range is minus 1 to 1. Okay, nothing changes. In the case of tan x, the graph is very unique. It's not defined as odd multiples of pi by 2, because if you check at pi by 2, it is what, beta? It is undefined. So at odd multiples means 90 degree, then not 180, then 270, all the odd multiples. 90 into 1 is 90, 90 into 3 is 270, 90 into 5, 540, and so on. Sorry, 450, and so on. Okay, so all the odd multiples, can you see this over here? 2n plus 1. What does this mean? 2n plus 1 times of pi by 2. 2n plus 1 is an odd number. If n is any integer, then 2n will be an even number. Add 1 to it, odd number. So 2n plus 1 represents odd number. This is nothing but odd multiples of pi by 2. This means odd multiples of pi by 2. It is not defined. So basically it means minus pi by 2, pi by 2, 3 pi by 2. All these values, the tan function is undefined. Let's draw the curve. X dash. y dash. Look at the curve, very interesting. Okay, and so on. Okay, I hope it makes sense to all of you. Please check. Excuse me. Yeah, 1 second guys, I can change this color. Okay, and again I'm gonna go like this. Okay, yeah, sorry, I hope this makes sense. So this is all what? This is pi by 2. Actually I can erase that green one, not required. This is not required. Okay, this is not required. Yeah, this is pi by 2. What is this, sir? This is again 3 pi by 2. Okay, what is this, sir? This value is again 5 pi by 2. Over here, what is this value, sir? Minus pi by 2. So the function y equal to tan x is not defined at these values. Means when you see this value, this goes to what value? Negative infinity on this side and positive infinity on the right hand side, plus infinity. It's going to plus infinity. Excuse me, 1 second. Sorry for the mess in the curve. Yeah. So all these values are tending toward plus infinity, and all these values over here are tending toward negative infinity. Please have a look. Okay, great. Yes. Yeah. So domain is everything, all real number except for the odd multiples of pi by 2. And range is what? All real numbers. Check here on this, every real number is counted. Means range is all real numbers. Repeat after every interval, means periodic in the interval of pi. Okay, got it? Check here difference. This value comes right after pi. Difference of pi by 2 and 3 pi by 2 is how much? Check here. 3 pi by 2 minus pi by 2. Difference is what? 2 pi, 3 pi minus pi. So 2 pi by pi. 2 pi by 2, what is the answer? Pi only, right? So this value repeats every after 3 pi by 2, 5 pi by 2. If you take the difference, periodic in what interval? In the interval of pi. Okay, makes sense. Now this is the curve for cot x, just the mirror image of tan x across y equal to x line. Okay, have a look. Domain is r minus n pi, range is all real here as well. This is not defined at multiples of pi, because cot x means, in cot x what happens? You have cos x by sin x. So sin x is 0 when we have multiples, integral multiple of pi. So 0 pi, 1 pi, 2 pi, 3 pi, minus pi, all these values, sin is 0. So cos pi sin will become what? Undefined, right? So in that case, at multiples of pi, it is undefined. Check here, minus 2 pi, minus pi, 0, then we have pi, 2 pi. At all these values, it is not defined. That's why it is removed. R minus n pi. N belongs to all integers. And what is the range? All real numbers. Again, repeats after the interval of pi. Get it? Okay. Cosec x, everything but the, again, everything the opposite to what the value we had for, what is it? Sine. Means sine was between 1 and minus 1. Over here it is after 1 and below minus 1. Okay, please check. So domain is all real except for n pi, same reason, because cosec means what? Cosec means 1 by sin x, and sin x is 0 for all x belonging to n pi. Okay, that's why remove the n pi values. Getting it? Okay, and range is everything but minus 1 and 1. Means you can't take the value between minus 1 and 1. So if you take the number line, this is the result. Minus 1, 1. So all of this on this side, all of this on this side, this over here is not part. Okay? Alright. Repeat after the interval of 2 pi again. Secant of x, same result, repeats after the interval of 2 pi. And what is this? When cos is 0, odd multiples of pi by 2. What is this, sir? 1 by cos, no? And cos x is 0 is when? At multiples of 90. So odd multiples of pi by 2 is not part of the domain. Range is again same as the cosec, same range. Graph is given over here, periodic over 2 pi. Okay. Okay, so this is it. Moving on. Some results now, very important results for angles. Sine of minus x is minus sine x. Okay, this is odd function. Cos of minus x is a cos x. Even function. Again, pi by 2 minus x will become sine because they are complementary in nature. Sine also remains. These two results come from complementary ratios. Complementary ratios. Okay. Cos of pi by 2, again same result. Negative because of what reason? Because of the cos value in which quadrant? Pi by 2 minus x. Pi by 2 plus x, sorry, is in second quadrant. It is in second quadrant and cos is negative in second quadrant. Hence we are getting here minus sign. Okay, because since sine and cos are complementary ratio, at pi by 2 cos converts to sine and sine converts to cos. Okay, get it? And same way tan to cot, sec to cosec. At pi by 2, no, sine converts to cos and cos to sine. We have sec that converts to cosec and cosec to sec, and same fashion tan goes to cot and cot to tan and cot to tan, because these are the pairs of complementary ratios. Okay, at pi it remains same. Sin pi minus x is same as sine. Cos pi minus x is same as cos. What about sine, sir? Minus plus means what are the signatures that of the number itself, minus and plus? That depends upon the quadrant rule. Have a look. Pi minus x. Pi minus x. Pi minus x is in which quadrant, sir? This is, sir, 0. This is pi, sir. This is pi by 2. Pi minus is in second quadrant. Second quadrant, which is the ratio? Sine. Sine is positive over here. Result will be what? Positive. Check here. Cos pi minus x. Cos remains cos, but it's in second quadrant. That's why negative. Getting it? So add the multiples of pi, means pi, 2 pi and all that. The sine, cos, tan, whatever the ratio are there will remain as it is. Cos remains cos, sine remains sine, cos remains cos. But the signature that you see, the signs that you see outside will come from the quadrant rule that we have learned. You all know, I explained you in the beginning itself. This is the quadrant rule. Please check. Okay. This session is going to be very, very important for the basics of trigonometry. Alright. Okay, sine pi plus x, again sine will remain same. Pi plus x is in third quadrant, sine changes to negative. 2 pi minus x is again fourth quadrant, sine will remain sine with the minus sign. Cos of 2 pi minus x, cos will remain cos, positive because fourth quadrant. This is where, sir? This is in the fourth quadrant. Fourth quadrant, cos is positive. Okay. Sum of the angles formula, cos x plus y, sine of x plus y, please check. So I'm not going to give you, I'm not going to read out the formulas because all written over here. You can of course get the access to the notes. Please remember all these formulas, very, very important. Sine x plus y, sum and difference of angles. These are the identities which is very important in this chapter, in PU2 syllabus, in PU1 syllabus, everywhere. Okay, very, very important. Some more identity, double angle formulas, half angle formulas. So learn it. Conversion between sine and cos, all of these are very, very important. Okay, have a look. Okay, double angle, triple angle formulas for sine, cos and tan. Conversion of cos to cos and sine, only cos, only sine and tan. Again, sum to product means here we have sum of ratios, here we have product of ratios. How do we get the result? Remember all these formulas. Okay, this and this is the same thing. Either remember this one or you can remember this one. Okay, I'm not spending too much time on this because these are the formulas you have to memorize over here. We don't have time to prove and derive right now each and every one of them. So you have to remember all the formulas. Very, very crucial. Okay, notes you already have. You can get the access and you start working on it. A plus b is 5 pi by 4. Okay, I'm looking for that. Okay, I want tan of a plus b. Let's apply that. Tan of a plus b, I'm applying tan on both sides. I think something I'll have. Tan of 5 pi by 4. 5 pi by 4. What is that? Is it true? Pi plus pi by 4? Correct, no? 5 pi by 4 is pi plus pi by 4. Right? 5 pi by 4 is 5 plus pi because 4 pi plus pi. Yeah, this is correct. I've rewritten this angle 5 pi by 4 as pi plus pi by 4. So I can reuse the relation. Have a look. Tan pi plus pi by 4. Which quadrant is this? This is in third quadrant, sir. Pi plus pi by 4 is third quadrant. Tan will remain tan itself. It does not changes. At pi it does not change. So tan angle will be pi by 4. And third quadrant tan is positive. Third quadrant tan is positive. Okay, sir. It means tan pi by 4 will be what? 145 degrees. So right hand side is 1, sir. What on this side we have? Tan of a plus b. What is tan of a plus b, sir? Formula is there. Tan a tan b, okay, 1 minus tan a tan b equals to 1. Do one thing, just expand it. Just expand this. Sorry, cross multiply this. Sorry, sir, it looks correct to me. If I cross multiply, I get this value, tan a and tan b. 1 minus tan a tan b. Okay, let's do one thing. Bring this over here. I'm getting a result actually. Tan a plus tan b plus tan a into tan b is equal to 1. I'm getting an interesting result. Have a look. I'm getting a interesting result, sir. Tan a plus tan b plus tan a tan b is equal to 1. This is what we got from what they have given. Now what are they asking us? 1 plus tan a, 1 plus tan b. Let's do one thing, expand it. So I get 1 plus tan b. I'm multiplying this 1 with this bracket. So I get same thing, 1 plus tan b. Now multiply tan a with that. So you get tan a into 1 to tan a, and the last one tan a. Okay, I got the result now. Answer should be 2. Tan b. Tan a into 1 is tan a, tan a into b is tan a tan b. Okay, check carefully what is this value. Tan b tan a plus tan a tan b. Tan b plus tan a tan b is nothing but 1. This value is 1, sir, and this value is also 1, sir. Answer is coming as 2. Answer is coming as 2. Please check. So we use over here quadrant rule. We use here that the property of at the multiples of pi, that ratio does not change. How to check the angles and the formula of identity. Good question. Okay, done. Let's move on. Visible, right? Let's move on then. Okay. So let's look at complex numbers now. So from where the need of complex number comes, remember this expression of roots of quadratic, we had, we had this one, minus b plus minus root d upon 2a. This is expression for roots of a quadratic, and when this d value becomes less than 0, we used to say that roots are not real. Roots are not real. So what are the roots in that case? The roots that you see becomes complex. The roots turn out to be, roots are complex now. What is the meaning of complex, sir? So if you see the hierarchy of number system, you start from where? Natural number, then whole number, then integers, rational number, irrational number, then you go to real number, and after real number you're going to combine imaginary together, real and imaginary. That result becomes complex. If I have to talk about that example you take, Z is the notation or symbol we use, not the integer one, the simply symbol that we use as a variable to notate a complex number which has two parts. X represents your real part and plus IY, where Y represents your imaginary part. So this is your real part of the complex number Z, and Y represents your imaginary part of complex number Z. I hope this makes sense. Right, guys? So if I talk about purely real or purely imaginary complex number, so in this case you'll have just Z as X plus I0. I is something that we use to notate our, I is called as iota. This I you see is called as iota. We'll talk about more. Okay, we'll talk about this more. Let me just talk about that later only. 1 second, guys. Let me talk about this one later itself. Okay, but I is the imaginary notation that we use to represent our numbers in imaginary side. Okay, so when I into 0 is there, means imaginary part is 0, and then you write another complex number. Let's say Z equals to 0 plus I Y, where there is no real part. So this becomes purely imaginary complex number. This is purely real complex number. Okay, as is mentioned over here, Z equals to A plus IB, where A and B, same thing is written over here as well. You can see what I explained, same thing is written over here. Moving on. Next is what? Algebra of complex number. Of course, if it's a number, means you can add them, subtract them, multiply them and divide them as well. So if you have two numbers, let's say Z1 equals to X plus IY and Z2 equals to a plus ib. Then if you're writing z1 plus z2, this becomes, you're going to add just the real part together. So write here x plus a and plus I times, add the imaginary part, so y plus b. So you add the like terms, okay, means add real to real part, imaginary to imaginary part. Same goes over here in the case of difference also. Difference means subtraction. Subtraction we all know is another form of addition, okay. So we can simply take x minus a plus I times of y minus b. So if I write it over here, if I am talking about z1 minus z2, I'll go like this, x minus a plus I times of y minus b. Difference of the real and imaginary part individually. Multiplication of two complex numbers, okay, very simple. So you're gonna go, this is going to be very as simple as that. You call as something, the property is distributive over distribution of multiplication over addition. That's we're gonna use over here. Let me show you. X plus iy we have, so, and over here we have a plus ib. So you're gonna multiply x with a plus ib plus iy with a plus ib. As I mentioned, distribution of multiplication over addition, okay, that's how we're going to use, okay. Now division of complex number, this is very very interesting. So when you're talking about this one, okay, this let's say if I have this result as x plus iy and a plus ib, what you do is over here you take this multiplication over here with a minus ib upon a minus ib, because when you do that, no, it becomes what, a square minus I square b square. Please check. It becomes, the denominator you check please. This becomes bacha a square minus I square b square. How come, sir? The formula that we have. You know, sum of the two numbers into their difference. A plus ib, a minus ib. The result is a square minus I square b square. Check here. A square minus, what is the value of I square? Minus 1 into b square. The value becomes a square plus b square. Now why are we doing this? Because our end goal is, whenever you are writing any complex number, the form should be always this, some real part plus imaginary part, like this. So when you remove the imaginary part from the denominator, you end up with only imaginary part in numerator, which is what I have over here. A and b can be rationals, okay, can be a fraction, but we cannot have imaginary part in the denominator. Let's move on. Okay, as I mentioned, we'll talk about iota in detail. So integral powers of I. Integral powers of I. First of all, what is I? So basically, remember this value minus of 1 root. What we had learnt earlier, we cannot find the root of this value because negative value does not have anything. For example, if I have minus of 4 or minus of 5 in the root, then basically what we do is, we replace this value by, in this we replace the value of I square as minus 1. Now check, you'll have root of I square, it becomes simply I. So what I basically means is minus of 1, root of minus of 1. So if you are going about this question, it will become what? Root of I square into 4, because I am replacing minus 1 into 4 as my I square into 4, this is not minus, so into 4 it becomes simply 2I. This is the imaginary part. Same way over here, if I have root 5 means I have minus 1 into 5, I write this as minus 1 as I square into 5, answer becomes I comes out and root 5 as it is. Okay, were you hoping that I'll get the value for root 5 also? Okay, this we cannot get this irrational to rational of course, but yeah, I can make this imaginary to, I cannot, this is not like not possible to find the root in the form of imaginary numbers. Okay, so integral powers of I. So basically, as I mentioned, first thing is very important, that I square is equals to minus 1. So if you're writing, let's say I cube, you write I cube as I square into I, it means minus 1 into, minus 1 into I. So this result becomes simply minus I. Okay. If I'm writing I power 4, now this is something very interesting. I square into I square, which is nothing but minus 1 into minus 1, this is going to be plus 1. Now I want to tell you a result over here. So whenever you were talking about I power n, right? I power n, and this n value is what? N value is equal to 4, 8, 12, 16 and so far, basically multiples of 4, then I power n bacha will always be equal to 1. Okay, so if you have powers of a I value iota as 4, 8, like this, multiples of 4 always, nothing else but multiples of 4 always, then I power n will be always equal to 1. Okay, otherwise we know how to solve it. If I have I power 5, I'll write this as I power 4 into I power 4 is 1, and into I will become simply I. I hope it makes sense. Now, so from here onwards, the formulas and the properties and the identities which is there for complex numbers. We have learned these for algebra, remember, x plus y the whole square. Same thing goes for the complex numbers also. If you have two complex numbers as sum, you're going to apply the identity of a plus b the whole square. Difference also remains same, b is a square minus 2ab plus b square. Here the cube also formula remains same. All remains same, nothing is changing over here. We just use this one if you remember in the previous case. Then I explained to this the previous quotient of two complex number. I use the formula of this only, right? Yeah. I hope it makes sense. Nothing is big over here. Very simple identities of complex numbers. Okay. The modulus and conjugate. Now this is very important, but not difficult at the same time. Modulus means the magnitude value, the value of the complex number. We can represent in the Argand plane also. We'll talk about that a little bit later. But right now, modulus means the magnitude. Conjugate means like basically if I write the conjugate, let's say complex number as a plus ib, then conjugate is written or represented, please check, by z bar. Like remember the transpose that in that part, so z bar, and in this case a remains as it is, just change the sign of imaginary part, imaginary part to negative, so minus ib. So sorry, what if I have a complex number z1 as 2 minus 3, okay, 2 minus i3, then what is the value of z1 bar? It will become what? 2 plus i3. So I am not saying that it will be always negative, I am saying that the sign will be reversed. Okay, if you have plus over here it becomes minus, if you have minus it becomes plus, as simple as that. Okay, now modulus, how you find modulus? So for modulus the representation is very simple, like this you write. Remember the magnitude result that we have, mod of z or mod of whatever complex number is given to you, and that is going to be simply squares of real and imaginary part. What is the real part here, sir? Please check. So if the complex number is defined like this, a is the real part and b represents your imaginary part. Am I right? Then what happens over here is the square of the real part, which is a square, plus the square of the imaginary part, which is b square, taken as sum inside the root will give me the value of a complex number, which is always going to be positive or equal to 0 for all z belongs to any complex number. Getting it? Yes. So this is a very simple concept, not a difficult one. Let's go through them one by one. Complex number itself is a very simple chapter. The questions might be difficult at times because there are a lot of calculations involved over here, but with patience, with right technique, you can get them right. When I say technique, I mean properly able to do the rationalizations, applying the identities that you know and the properties that you have. You should be able to use them together, then only you can get the results quickly. A complex number z is purely real if and only if z bar equals to z. Okay, of course, because if it is talking about purely real, sir, it means I'll have the number as a plus I0. So if you take z bar also, sir, what are the value going to be? Same only, a minus I0. Since this value is 0 only, it does not matter. So z and z bar will be equal to each other. If you talk about purely imaginary, you let me know whether this is true or not. Yeah, correct? If you talk about this, you'll have only 0 plus IB or 0 minus IB. So basically the minus sign will be introduced over here. We can also write this as z bar plus z equal to 0. This is the case for purely imaginary complex number. Okay. Some properties of modulus, mod of z is 0 means either complex number is 0. That what it means is basically real and imaginary part both are 0. Okay. Now mod of z or mod of conjugate of z or mod of minus of z will always be same, does not matter. Means if you find the modulus of the complex number, modulus of the conjugate of complex number or modulus of negative of complex numbers, the result will always be same. Okay. The real part lies from where to where? Basically always less than equal to, I think it's mentioned over there. Yeah, the real part is basically always less than equal to mod of z. That's why it goes from where to where? Minus to plus. Getting is clear? So goes for, same case goes for imaginary also. It's all written over here, so let's not rewrite this. Yeah, same goes for imaginary part also. Moving on. Some more properties, z into z bar is given by z square, because if you talk about modulus over here, what happens then? If you apply modulus on both sides, it will become what? Mod of z into mod of z bar. We just learned they are both mod of z, so it becomes mod of z the square. Okay. Now, if you have two more complex numbers in product, you can simply take them individually the way I used over here. Yes, and the complex, if you have in the ratio or the quotient, you can take the modulus again individually at the same time. Okay, again this is the same property we use, remember, z1 plus z to the whole square minus whole square plus whole square. Okay, and if you add them, what happens if you add them? You'll get this two part cancelled, right? If you add them, you'll have twice of z1 square, twice of z2 square. I hope it makes sense. Now, if you introduce here coefficients, instead of coefficient being 1 1 everywhere, if you introduce a z1 and b z2 and add the same thing, you'll get the result as coefficient square taken as sum times of the same result. Means over here, if you check, what is the coefficient, sir? The coefficient value is a equal to 1. Over here, coefficient value is b equal to 1. If I'm comparing this from here, okay, a value is 1, b value is 1. So, of course, what is this 2 represents? Square of a, which is 1, square of b again is 1, because we have a and b 1. So, we'll get a square also 1, b square also 1. If you add them, you get 2. The same way, if you have other coefficient also taken in this format, means az1 minus bz to the whole square, bz1 plus az to the whole square, then very simple, your result is given by squares of the coefficient taken as sum into z1 square plus z2 square, provided a and b are real numbers. Okay. Moving on. Properties of conjugate. Again, as I mentioned, to solve questions in complex numbers, you need to know all the properties of conjugate, modulus, all these are very, very important, okay, alongside rationalization and identities involved. Have a look. If you're taking conjugate of conjugate, it becomes the complex number itself. This I explained right now for the real part if you're adding, and this is again same thing for imaginary part, okay. When you subtract the numbers like this, you're going to remove the, what is it, real part in this case, that's why you only imaginary left. If you add them, what is going to happen? I'll show you. If you have x plus iy, take the conjugate, x minus iy. If you add them, you'll get this cancelled. You'll have only 2x, which is nothing but twice of real numbers. If you subtract them, you'll have only imaginary part left. That's why twice of I imaginary numbers of imaginary part of z. Okay. This I already explained. For purely real number, z and z bar are equal. For purely complex, imaginary number, z plus z bar is equal to 0. I explained, I think, right now over here somewhere. Here. Yes. Okay, guys. Another set of formula, z into z bar will be given as, what is this, sir? What is this? Why it is like this? If you remember, this represents mod of z the whole square. What is the mod of z value? Root of a square plus b square the whole square. Check this out. What this becomes? A square plus b square. A square represents real part square and b square represents imaginary part square. Similarly, go through all the processes, you'll get the result. If you have conjugate on the sum or difference, it can be separated on individual complex numbers. Quotient also, as I mentioned, it can be taken the conjugate on individual numbers. We're going to use a question on this. We're going to solve a question on this. Taken a product, if you have the two complex numbers as product, complex conjugate on that, you can separate the conjugate and then take the product at the same time. Okay. Okay, guys. So if you have alpha equals to f of z, then alpha bar becomes f of z bar. Okay, where alpha becomes to any complex value. Okay. Now let's talk about the last concept, which is very important: Argand plane and polar representation. Check here. Okay. So this y-axis in this case represents your imaginary axis actually. Okay, and this is your x, which is called as real axis. So if you have a number z equals to x I y, what it means is somewhere over here, this is the x coordinate, this is the y coordinate. This will be your x comma y, I guess, yeah, and this will be your angle theta. Okay, then this value is called as r. This value is called as r, and you find r value as, check here carefully, this value represents your y and this value represents your x. So r you find using the Pythagoras theorem as root of x square plus y square. Correct? R you find from the Pythagoras theorem, because r represents this length. Let's say this is origin O and this is the point A. Then r will be what? The line OA. How do you find OA? So using the Pythagoras theorem, if I call this point to be point B, I can write AB square plus OB square equals to OA square, which means OA is equals to root of AB square and OB square. So x square plus y square. This is how you find r. Okay. Now how to write the, let's say I have to write the coordinates of the point A. Right now it is in the Cartesian form x and y. If I have to write in the polar form, I can simply take the component of r across x and y axis. If you take component of r across x axis, this value turns out to be r cos theta, and if you take across y axis, this value comes out to be r sin theta. So you can simply write x value as, check here, the x value as r cos theta and y value as r sin theta, r sin theta. If you want to make sure it is correct or not, try this out. X square plus y square, okay, this becomes equals to r square, because we'll have both places r square, and in the first term you'll have, if you take common, you'll have cos square theta. Over here you'll have sin square theta. Okay, this value becomes equal to 1. So you have this as, please check, x square plus y square equals to r square. And if you check here, we just got this result. Take root on this side, this square gets out, that's the value. I hope it makes sense. Yeah, this we got using Pythagoras theorem, and this we got using the identities and component of r across x and y axis, y representing your imaginary axis and x representing your real axis. Okay, cube roots of unity, when you talk about cube root of unity, basically what it means is the number cube is equals to 1. From here you get what? Usually if you are solving this, you get this as x cube minus 1 equal to 0. We say that, sir, we have one of the factor as x minus 1. What is the other one? You'll have, sir, x square plus x plus 1. Okay, if you're not able to recall this, let me just do it properly for you so that it makes sense. Yeah, guys? Okay, let's get back to this now. Yes. If I have this as 0, what can you factorize this? X cube minus 1? Yes, we can, sir. X minus 1, x square plus x plus 1. If you remember, this is the formula, right, for a cube minus b cube. Yeah. So from the first bracket that you have, you're going to get the result as x equals to 1. This is your first root. And the other one basically will become omega and omega square, where omega actually is what? Minus 1 by 2 plus root 3 by 2 I. Because in this case, if you check the other quadratic that you have, x square plus x plus 1, the d value will come as negative. Please check. What is the d value? B square minus 4ac. D value will be over here, sir. D value will be b square minus 4ac. Check. What is b square? Square of this is 1. So 1 minus 4 into a is also 1, c is also 1. So 1 minus 4, which is how much? Minus 3. So we're getting here the value of d is less than 0. Means the roots of this quadratic will be what? Negative. So for we know that if the cube is there, means we'll have 3 roots. The first root is always 1 from the first bracket, and the other roots are the complex roots. What is it? So minus 1 by 2 plus minus root 3 by 2 I. Okay, this is your result of the roots of unity. Okay, starting from where, but starting from x cube minus 1 equal to 0, factorizing this x cube minus 1 as x minus 1 into this particular formula we have, a cube minus b cube, a square b square plus ab. Okay, and then finding the d value, the discriminant of this other root that you have, other factor that you have, you get the value as negative. It means you'll have the complex result over here, and as it turns out, the result is going to be what? For the roots, minus 1 by 2 plus minus root 3 by 2 I, and this is first one. If you take plus sign, it is given as omega, minus sign is given as omega square. How can I say that? If you take square of this value, you get this result. If you square it up, if you square on both sides on this particular expression, you will get the omega square as minus 1 by 2 minus root 3 by 2 I. I hope it makes sense. So this is the end of your concept side. Let's quickly get to solving the questions. What should be the positive value of p so that the magnitude of this, where I is given as, basically I square is given twice of this. Let's find the magnitude of this, sir. So 3 square plus p square in the root is twice of, 3 square upon 4 square plus p square. Okay, check here. So this is going to be 9 plus p square. Take the whole square. You're going to get 4 times of 9 upon 16 plus p square. Okay, expand. You'll get here 9 by 4 plus 4p square. And what's you have on this side? 9 plus p square. Move on this side, move this on this side. 9 minus 9 by 4 equals to 3p square. Please continue. 9 minus 9 by 4, 3p square. You'll have 36 minus 9 upon 4, 3p square. 27 by 4, 3p square, 3 times 9, right? So I'm getting the value as p square equals to 9 by 4. It means p value is plus minus 3 by 2. What are they asking us? They are asking us only the positive value of p, which is going to be only plus sign. Hence answer is, sir, option C. Option C. Makes sense? First question, answer is option C, 3 by 2. Have a look one more time. Okay, next, they're saying that if z minus 1 is purely imaginary, then find which of the result is applicable. Okay, purely imaginary, if you remember, if I take z minus 1 and z plus 1, even if it is a real part, even if it is a real number, it will be form of complex. So we know that if I have a complex number x, okay, and if you have, if x is what, purely imaginary, if it is purely imaginary, then I can say that x plus x bar will be, sir, equal to 0. So I'll write this plus bar of this, means we're gonna go like this. Yeah, one second guys. Okay, over here, sorry, we'll go like this, excuse me, where is it, here, one second, yeah, so we'll go over here, z minus 1 and z plus 1, the conjugate should be equal to 0. This result we are using, x plus x bar is 0. Let's continue. We know that the property, we know that we can just separate the conjugate. We'll get z bar minus 1 upon z bar plus 1 equal to 0. Now do the multiplication. You'll get z into z bar. You'll get minus 1 into this will become simply minus z bar. You'll have z into 1, so plus z, and minus 1 into minus 1, it becomes minus 1. Okay, excuse me, yes, the plus sign actually over here. Now multiply this into this, cross multiplication, I get again z and z bar. Z into minus 1 is going to be minus z. Z bar into 1, z bar into 1 will become what? Plus z bar, and again minus 1 into 1 will become minus 1 equal to 0, because whatever you have the denominator, multiply on this side will be 0 only. If you're not sure, please do your own calculation. Okay, take the product of this cross multiplication, and the result in the denominator will go on this side as 0. Check here. So minus z bar and plus z bar cancels, plus z and minus z cancels. We have z into z bar. How much is that? Z square. What is this also? Same thing. Z square, and we have minus 2 equal to 0. From here we are getting 2z square, okay, equals to 2. Check this out, 2 and 2 cancels. We have 1 over here, means mod of z square, mod of z square is equal to 1. So z is equals to what? 1. Because it's a mod, we cannot have negative. Answer will be of course B. Okay, B. Correct? Makes sense, guys? A simple question of calculation and simplification. Okay, the property that we used over here is x plus x bar equals to 0. Okay, where x represents z minus 1 upon z plus 1. Moving on. Alright, on an Argand plane, which is, this is your real part and this is your imaginary part. Okay, cube root of unity represented is what? So basically if you plot it out, no, I just showed you the cube roots, right? 1, 0 is 0.1, one of the root is 1, other root is over here. This will be with, again, yes, got it now? Yeah, 1, 0, this will be as it is. Please check. Minus 1 by 2, minus root 3 by 2, you have minus 1 by 2, root 3 by 2. The 3 points are mentioned over here, point A, B, C. If you find the length AB, BC and CA, you can find it no problem, because you have coordinates noted over here for point A, B, C. So you're going to find them. If you find the coordinates and the length, you'll get always the value as root 3, root 3, root 3. You don't have to solve this question. Remember this, on Argand plane, cube root of unity is giving you what? Giving you always a vertex of equilateral triangle. So you can solve it right now and get the result as root 3 everywhere. And remember this also in the exam, is going to help you to get the result. Okay, answer will be option A. Okay, so this is the end of your session today. I hope you enjoyed it. Let me know what you feel in our live classes, and that's all for today. See you on the next time. Till then, take care. Bye bye. All the best.